Close your eyes for a moment and picture this. A bustling warehouse, maybe the size of several football fields. In one vision, it's a perfectly orchestrated ballet robots whirring, forklifts gliding. Every single item, from the smallest screw to the largest pallet, knows its precise destination. In another, it's a sprawling, chaotic maze where crucial shipments are delayed, and the search for one specific box feels like a treasure hunt with a missing map. Whichever image resonates with you, you've just glimpsed the fascinating world we're about to explore. Welcome to the deep dive. I'm genuinely thrilled because today we're pulling back the curtain on the often invisible yet absolutely critical systems that keep our entire modern world supplied and humming. We're going on a journey that's packed with crucial facts, surprising insights, and, well, a deep understanding of what makes our global logistics tick.
And for this particular deep dive, we're dissecting the intricate world of warehouse and inventory management systems. Our foundation for today's discussion comes from a meticulously summarized textbook designed to give you, a shortcut to being truly well-informed. It's brimming with essential facts, precise definitions, and key numbers that are perfect for those aha moments and a solid grasp of the subject.
That's precisely it. Our mission here, as always, is to extract those vital nuggets of knowledge from this rich material. We're talking about everything from the ingenious ways companies store mountains of goods to the advanced automation that moves them around. We'll be highlighting the crucial definitions, specific numbers, and the undeniable facts that underpin this complex industry. You'll walk away with a clear picture, ready to understand the unseen efficiencies all around you.
Because truly, a deep understanding of these systems isn't just for logistics professionals. It's for anyone who's ever ordered something online and wondered how it arrived so quickly, or simply for anyone curious about the foundational efficiencies that underpin our entire modern economy. Every package on your doorstep, every fresh item on a store shelf, it all flows through these intelligently designed networks. So how do all those things get to you? Quickly and reliably. That's exactly what we're diving into today, Nay.
Now, the foundation.
Strategic storage systems.
Okay, let's unpack this and begin at the absolute core. The strategic storage systems themselves. When we talk about a warehouse storage system, what are we really defining here beyond just, a place to put things?
That's a great starting point. A warehouse storage system is fundamentally a structured, methodical approach to organizing and managing goods within a warehouse space. Think of it less as a passive storage unit and more as an active strategy to ensure efficient space utilization, maintain inventory safety, and guarantee smooth, timely accessibility of products.
So it's not just about stacking boxes, it's about a strategic architectural plan for efficiency. What's the ultimate goal behind such a system?
Exactly. Its primary purpose is multifaceted: to keep products secure and well-arranged, while simultaneously optimizing every available square and cubic foot of storage capacity. By carefully selecting and incorporating suitable equipment, designing the most efficient layouts, and deploying appropriate technologies, these systems empower businesses. They help maintain order, significantly reduce the time spent handling products, and ultimately improve overall operational efficiency across the entire supply chain. It's about making every resource, especially space, count.
And sometimes the most effective methods are also the simplest. Let's look at bulk storage for solids. This sounds pretty straightforward, but tell us more about its applications.
It is perhaps the most visually intuitive. Bulk storage for solids is exactly what it sounds like. Storing products directly on the warehouse floor, often in massive unpalletized quantities. You might also hear it referred to as floor-stacked storage. This method is particularly well suited for durable items that don't require delicate handling or specific racking. Think raw materials, large quantities of packaged goods that can withstand their own weight, or products that move in and out of the warehouse very quickly without needing individual item access. It's a low-tech, high-density solution when used appropriately.
As we move up a notch in complexity, we invariably encounter the general concept of pallet storage systems. These are the true workhorses of many modern warehouses. What defines them?
Fundamentally, pallet storage systems are material handling systems that use robust metal shelves, or racking, to store pallets of materials in horizontal rows. They're specifically designed to utilize vertical space. Where bulk storage is about spreading out, pallet storage is about building up. It's a key strategy for optimizing floor area by taking advantage of height.
Within that broad category, we have several specialized approaches. One common one is block stacking. What differentiates this?
Block stacking is a warehouse storage method where pallets, crates, or boxes are stacked directly on top of each other, forming a block, often without the use of permanent shelves or racking. It's similar to floor stacking, but utilizes pallets as the structural base for each stack.
And a crucial distinguishing factor here, which might be a key point for understanding, is that because there are no permanent shelves, it makes it a very cost-effective way to store similar goods, particularly those that don't require frequent access. You're essentially building a dense, self-supporting block of identical products, maximizing cubic utilization with minimal infrastructure.
Then we escalate to more engineered solutions, such as drive-in and drive-through racking. These are fascinating systems. How do they work?
These are high-density pallet racking systems where the name really describes the action. Forklifts literally drive into the aisles to load and unload goods. It's a way to significantly increase storage density compared to traditional pallet racking.
They represent a highly compact storage solution, frequently employed in warehouses where cubic space is at an absolute premium. The robust racking structure itself supports the full weight of the pallets. Now, here's a critical detail for understanding their application. These systems are most suitable for high-stock product lines where FIFO, first in, first out, is not a requirement. This is a fundamental concept in inventory management where FIFO stands for first in, first out, meaning the oldest inventory is sold or used first.
Ah, right.
So if your products are non-perishable or don't have strict shelf life requirements, these systems can offer significant space savings by not needing to maintain clear access to every individual pallet for FIFO rotation. It's a strategic choice with clear implications for product types.
That's a really important distinction. If FIFO isn't a concern, you can really pack things in. Okay, following that, we have pushback racking. What's the mechanism behind this system?
Pushback racking is another type of high-density pallet storage system, but it uses a series of nested carts or gravity-fed rollers to store pallets several deep in a lane. As a forklift loads a new pallet, it pushes back the previous pallet in the lane, creating a very dense storage configuration that still allows for a relatively easy access.
What's a key operational rule for pushback racking that makes it so efficient and perhaps a good point to remember, maybe for an MCQ point?
A critical rule for its implementation, good point, which optimizes its efficiency, is that there should be no mix of product lines within any one lane of pushback racking. This maintains order and prevents product confusion. However, it's perfectly acceptable and common for different lanes in the same row to hold different product lines. This specificity is key to its operational effectiveness.
Moving on, we encounter perhaps most ubiquitous system, adjustable pallet racking, or APR. Why is this system so widely used?
APR is a highly versatile and selective storage solution specifically designed for palletized goods accessed by forklift trucks. Pallets are reached from aisles whose dimensions are carefully calibrated according to the mechanical trucks that will be operating within them. It is, probably the most widely used pallet racking system globally due to its adaptability.
And for good reason. APR offers incredible flexibility and versatility, providing excellent direct access to almost any stock location. It's simple in concept, easy to lay out and reconfigure in a warehouse, and a significant practical benefit for any operation. Damaged parts are easily replaced. That combination of flexibility, accessibility, and ease of maintenance truly underpins its widespread adoption.
Next, we have double deep racking. As the name suggests, it adds another layer of density.
Exactly. This is a pallet racking system designed to store two pallets back to back on the same side of an aisle. It's typically employed in warehouses to store pallets of similar items, and it's particularly ideal for stock that has a medium or long-term shelf life where you don't need constant individual access.
And to access those two pallets deep, you do need a specific piece of equipment, a double-reach forklift truck. This specialized forklift has an extended mast or telescopic forks that can access not just the front pallet, but also the second pallet deep into the racking. The mechanism allows unit loads to be stored mechanically by forklifts, moving along aisles parallel to the racking systems, achieving higher storage density while still maintaining relatively quick access compared to, say, drive-in systems. It's a clever balance between density and accessibility.
When space is truly at a premium, especially vertically, powered mobile racking comes into play. This sounds like it literally moves to create space. How does that work?
Precisely. This system features a movable base that supports the racking, allowing access to multiple shelves by creating a single working aisle only where and when it's needed. These motorized bases are electronically powered and guided by rails embedded in the floor, and they essentially slide the racks together to minimize unused aisle space.
What's truly ingenious about its efficiency, particularly for fast aisle access, that seems like a key benefit.
Yeah, for rapid aisle access, you can use a simple push-button control or ergonomic handles to move up to 6 aisles simultaneously. This system often finds its most critical use in applications like cold storage, where the operational costs associated with maintaining temperature and the value of cubic space are exceptionally high. That makes maximum utilization absolutely critical. It's a significant investment, sure, but it pays off dramatically in high-value, high-density environments.
And for very fast-moving items, particularly those requiring strict rotation, pallet live storage sounds like a dynamic solution. What are its other names, and how does it optimize efficiency?
Right. You might also hear it referred to as gravity flow racking or pallet flow racking. This system is brilliant because it optimizes warehouse efficiency by ingeniously utilizing gravity and a dynamic storage system. It's made up of inclined gravity roll conveyors laid out side by side at multiple vertical levels, creating a channel where pallets flow forward.
So products automatically present themselves for picking, like a vending machine for pallets.
Exactly. That's a good analogy. The beauty of this system is its suitability for very fast-moving product lines, where FIFO, first in, first out, is essential. It automatically refills empty locations as products are picked from the front, and crucially, it provides a physical separation between picking operations at the front and replenishment operations at the back. This eliminates traffic congestion and truly streamlines the workflow, ensuring fresh product always comes first.
Finally, within this foundational section, we have small item storage systems. These might not be as grand as a high bay warehouse, but their impact on efficiency for detailed inventory must be immense.
Absolutely. As the name suggests, these are specifically designed to store and organize those myriad smaller items, components, or spare parts within a warehouse, workshop, or even retail backroom. Their primary goal is to improve workflow, minimize search time, and make item location and retrieval significantly easier.
What are some common examples we might encounter? The actual bins and shelves.
Examples are quite varied. They include traditional shelving units with adjustable levels, specialized tote bins that slot into racking, dedicated drawer units for high-value or very small components, and even dynamic systems like mobile and live storage options adapted for smaller items. These systems might look simple, but their precise organization of small components is critical for preventing errors and maintaining operational flow in many industries. 2. The movement. Types of conveyors.
Okay, so we've extensively covered how items are strategically stored. Now let's talk about how they move, transitioning from static storage to dynamic movement with an introduction to the world of conveyors. These are truly the arteries of a modern warehouse, aren't they?
Indeed they are. When we talk about fixed path conveying, we're referring to specialized machines that move materials along a predetermined set path. This is usually between two fixed points within a facility, creating a continuous, predictable flow.
And their versatility is pretty impressive, isn't it? They're used for everything from accumulating goods and temporarily storing packages to changing elevations in a facility and even providing a continuous work surface for progressive assembly or processing tasks. They keep things flowing without constant manual intervention, reducing the need for forklifts in specific areas.
The simplest and usually least expensive category is gravity conveyors. These are incredibly useful, where material needs to be moved for short distances and the movement requirements are relatively straightforward, often relying on a slight incline.
What are the primary types of gravity conveyors, the ones you'd likely see?
The three most common types are chutes, skate wheels, and rollers. You've almost certainly seen them in action in package handling facilities or even grocery store checkouts. They rely on the natural pull of gravity, making them both cost-effective and energy-efficient for basic transport tasks.
Moving into powered options, we have horizontal powered conveyors, specifically what we call live rollers. What kind of loads are they typically designed for and over what distances?
Live rollers are designed to move material over moderate to long distances, where gravity isn't sufficient or consistent enough. It's important to understand their load capacities. These are commonly used for loads weighing between 14 to 23 kilograms in warehouses, making them versatile for many standard packages. However, they are robust enough to handle loads up to 45.35 kilograms and can even carry irregular shapes in containers, making them quite adaptable.
Here's where it gets really interesting for managing flow and preventing bottlenecks. Live roller accumulation conveyors. They sound like they act as a buffer, is that right?
They do, precisely. These are critical for regulating the flow of products into downstream operations, essentially providing a temporary buffer for excess products when a processing line or workstation might be momentarily backed up. They ensure a smooth, continuous flow without forcing items to stop abruptly.
And I understand there's a need for proper product alignment with these and two distinct types of powered accumulation conveyors. Can you break those down?
You're absolutely right. A critical detail to remember is the requirement for proper product alignment when using accumulation conveyors to prevent jams. Furthermore, there are two distinct types of powered accumulation conveyors that are vital to differentiate: zero pressure and non-contact. With zero pressure accumulation, there's no line pressure between products, meaning they can stop bumper to bumper without actually pushing or damaging each other. This significantly reduces damage to fragile items during accumulation.
Okay, so they can touch gently.
Right. Then, non-contact accumulation takes this a step further, ensuring products are always separated from each other by a small, safe gap. This provides an even higher level of protection, which is crucial for very delicate items.
Then we have slider bed and roller bed conveyors. How do these differ and what are their primary advantages?
Okay, the slider bed consists of a moving belt that operates across a continuous steel support bed. The roller bed, on the other hand, uses a belt that moves over a series of rollers. And here's a key fact for comparison, maybe another MCQ point. The slider bed is typically the least expensive powered conveyor option available due to its simpler construction.
Ah, good to know.
These belt conveyors offer stable support, are excellent for handling heavy loads, and can be operated at high speeds. This allows for the transportation of many different load types, including loose components, bags, or items that might struggle on roller conveyors due to their shape.
To keep the material flowing through turns and corners within a facility, we use roller curves and built-turn conveyors. What's the main difference between these two for changing direction?
The distinction is quite important for specific applications. Roller curves are generally less expensive and more common, often using tapered rollers to guide the product around the bend. They can be self-powered or slave-driven by the main conveyor line. Belt curves, on the other hand, are typically used when you need to maintain precise product orientation and spacing as it navigates a turn, which can be crucial for subsequent operations like scanning or sorting. The belt ensures the item stays exactly where it should be.
For more complex routing, like directing products to different destinations, we rely on sortation conveyors.
Yes, sortation conveyors are specifically designed to divert a product from one main conveyor line to another, acting like automated traffic cops for goods. Sortation is an ideal solution for a variety of applications, separating products from in-feed conveyor lines to specific shipping lanes, directing items to palletizing operations, routing products to specific packing stations, or really any other application where items need to be intelligently distributed across different paths.
If system flexibility is desired, or if floor space is particularly congested and valuable, powered overhead conveyors offer a clever solution by utilizing vertical space, taking it off the floor.
Exactly. They essentially lift the material handling above the main floor, freeing up valuable ground-level space. The advantages are clear. Material flow paths are easily established without disrupting floor operations or creating ground-level obstructions. This also offers an added benefit of providing drivers and other equipment on the floor with some environmental protection from overhead movement.
And finally, when you need to move heavy loads strictly between different vertical levels in intermittent flow operations, especially where horizontal space is limited, we bring in vertical conveyors.
These powerful machines, which can automatically move products from one floor level to another, are typically referred to by their abbreviation, VRCs. That stands for Vertical Reciprocating Conveyors. It's a key acronym to remember, representing a crucial piece of equipment for multi-level facilities, allowing vertical transport without the need for ramps or elevators for every item. 3. The automation. Automated Storage and Retrieval Systems, ASRS.
We've talked about how items are stored and how they move. Now let's talk about the pinnacle of modern warehouse efficiency, automated storage and retrieval systems, or ASRS. This is where warehouses truly come alive with advanced technology. Tell us, what fundamentally is an ASRS?
At its core, an ASRS, which stands for Automated Storage and Retrieval System, definitely one to remember, is a sophisticated computer-controlled system designed for automatically storing and retrieving items within a warehouse. It's a huge leap beyond manual systems, built for speed and precision.
So it's not just about moving things, it's about intelligence driving that movement, like a giant robotic librarian.
Precisely. That's a good way to put it. It utilizes robots, automated cranes, and various other technologies to move and store items within a grid or shelving system. These systems are specifically designed to handle a very high volume of loads being moved both into and out of storage with incredible speed, accuracy, and often without human intervention in the core storage area. It's truly a game changer for throughput and error reduction.
When we look at the basic components of an ASRS designed for unit loads, what are the 4 core elements that make up such a system?
there are four fundamental components. First, you have the storage medium itself. This is the specialized racking or structure where items are held. Second, there are the storage and retrieval machines, which are the automated devices like cranes that operate within that medium. Third, you need an in-feed and out-feed system to efficiently get items into and out of the ASRS. And finally, tying it all together and orchestrating every movement is the controlling computer.
Let's focus on the in-feed and out-feed system for a moment. What exactly do these systems do, and can you give us an example, something tangible?
Sure, these systems are the crucial interfaces that efficiently move materials into and out of the ASRS machine or production line. They can be integrated into a single unit or operate as separate components, depending on the system's design. A very common and essential example of such a system, often seen connected to an ASRS, is an AGV. Remember that one. It stands for Automatic Guided Vehicle. These autonomous vehicles transport pallets and other loads to and from the ASRS, acting as its automated logistical support.
Here's where the brain of the operation comes in, the controlling computer. What's its multifaceted role in managing such a complex system? It sounds critical.
The computer's role is absolutely central. It's tasked with managing all incoming and outgoing material flows, continuously monitoring the status of the pallet racking, knowing exactly what stock is located in each specific location, which locations are empty and available, and orchestrating all the crane movements within the system with microsecond precision. It's the central nervous system ensuring flawless operation.
And what does a typical ASRS installation look like in terms of its physical scale and the equipment involved? Are we talking huge structures?
Oh yes, a typical ASRS installation often consists of remarkably high bay pallet racking. For understanding the scale, installation heights of 45 meters or more can be achieved, creating immense storage density. The typical operating aisles for standard pallets can be quite narrow, often around 1.5 meters, optimizing every inch of floor space.
Wow, 1.5 meters, that's tight.
It is. And the heart of the movement within these towering systems is often the stacker crane. This consists of a robust vertical mast or a pair of masts supporting a unit load handling mechanism, capable of being precisely raised or lowered to any storage level.
These automated systems have some truly diverse applications across different industries. Can you give us a few examples beyond just standard pallet?
Certainly. We see them used for small item storage in intricate installations, utilizing specialized mini cranes, often in e-commerce fulfillment centers. They're critical for long load storage of items like metal bars and tubing, often utilizing cantilever racking in support of manufacturing operations. You even find them in specialized applications like paper reel handling, where overhead traveling cranes are fitted with delicate vacuum lifting heads to manage heavy yet fragile paper reels without damage.
A key term here that keeps coming up is the high bay warehouse. What's the precise definition of this? Those height numbers seem important.
They are. A high bay warehouse is a storage solution specifically characterized by its impressive verticality. It has a minimum height of 12 meters and a maximum height that can reach up to approximately 50 meters, emphasizing those heights. 12 meters minimum up to 50 meters maximum. This type of vertical storage is explicitly designed to optimally utilize available cubic volume, pushing storage upward to reduce the footprint.
And within the context of these towering high bay structures, we sometimes hear terms like clad rack warehouse. What does that refer to? Is the racking the building?
Essentially, yes. A clad rack warehouse is a specific type of high bay storage solution where the racking structure itself is not just an internal framework. Instead, it supports both the load of the goods being stored and the load of the external side and roof cladding of the warehouse building. This creates an incredibly compact, integrated assembly where the racking is literally part of the building's structural integrity. The source material also briefly mentions roof-on-rack in a broader context, maybe related to vehicles, but for our deep dive into warehouse systems, it's crucial to focus on these immense warehouse structures. Here, the racking is a primary support for the entire building envelope, making it a highly integrated and cost-effective construction method for high bay storage. Efficiency. Performance measures of material handling systems.
So we've explored the physical structures and the sophisticated automated systems that make them hum. Now, let's shift our focus to how we actually measure the success and effectiveness of these complex material handling systems. This is all about performance measures. How do we quantify efficiency in such a dynamic environment?
That's a crucial next step. A performance measure can be defined as a metric for quantifying efficiency and DOTR effectiveness. To clarify that distinction, efficiency specifically describes how economically, in terms of resource utilization, like time, energy, money, various tasks are performed within the system. It's about getting the most out of what you put in, minimizing waste.
One of the most fundamental metrics we track and intuitively understandable is vehicle travel distance, or equivalently, travel time. Why is this such a key indicator?
It's absolutely central because it directly relates to fuel costs, labor hours, equipment wear and tear, and overall throughput. We can break this down further into two categories: departmental travel, which is movement within specific departments, and then intra-departmental travel, which measures movement between different departments.
Okay, within versus between departments. Got it.
Right. What's crucial to measure is the average loaded or empty vehicle travel. A particularly insightful measure that helps assess utilization is the ratio RLE. That stands for run length encoding, specifically used here for measuring vehicle travel. The formula is elegantly simple. RLE equals TL over TE.
RLE equals TL over TE. What do TL and TE stand for?
TL represents the total loaded travel time, and TE represents the total empty travel time. This ratio provides a clear picture of how efficiently vehicles are utilized. A higher RLE often indicates better utilization of loaded trips, less empty running around.
Expanding on that, we can also look at vehicle travel proportions, which seems to categorize what a vehicle is doing at any given moment. Is it busy or just sitting there?
Exactly. Essentially, a vehicle can be in one of three states at any time. It's either traveling loaded, traveling empty, or it's idle. And that idle time, particularly time spent waiting in a parking area or between tasks, is a critical performance measure because it represents underutilized capacity. Travel time percentages are typically calculated as the fraction of time that a device is spent traveling loaded, traveling empty, and waiting in an idle state.
So there's a formula for the total time breakdown.
Yes, for a complete picture, the total time for a vehicle, let's call it T, is calculated as T equals TL plus TE plus TI, where TL is the total loaded travel time, TE is the total empty travel time, and TI is the total idle time. Understanding these proportions helps pinpoint bottlenecks, identify opportunities for better scheduling, and understand overall equipment utilization.
So when we're setting up these metrics, what truly distinguishes a good set of performance measures from one that might miss the mark? What are the characteristics of an effective performance system?
That's an excellent strategic question. When defining a set of measures, they should possess four key characteristics to be truly effective. First, inclusiveness. This means that good performance of one particular component of the system should not be possible without similar performance from other system components. They're all interconnected, so you need a holistic view.
Right, you can't have one part shine while another fails.
Exactly. Second, universality. The system should allow for comparisons across a wide range of operating conditions, making the metrics broadly applicable and benchmarkable. Third, measurability. All data required by the measurement system should be available at a reasonable expense. The cost of measuring shouldn't outweigh the benefit derived from the insights.
Practicality is key there.
Definitely. And fourth, consistency. The measures should provide meaningful insights into the overall material handling system performance with respect to the organization's overarching objectives. These 4 points, inclusiveness, universality, measurability, and consistency, are vital for any robust measurement system that genuinely helps drive improvement. V's, the tools, materials handling equipment.
Now that we've grasped the bigger picture of systems and how we measure their performance, let's zoom in on the specific tools that make all this physical movement possible. The incredibly diverse world of materials handling equipment. First, let's formally define what we mean by a material handling system, or MHS. What's the full definition?
Absolutely. An MHS, which stands for Material Handling System, another important full form, could be formally defined as the set of pieces of equipment that make possible the physical movement within the distribution chain, including the production chain and the warehouse of raw material, work in progress, and finished goods. It encompasses all the physical infrastructure and machinery used to move anything, anywhere, within the logistical flow.
And when we consider the various methods of material handling, it's quite a spectrum, from the most basic to highly advanced automation. Can you list the main categories?
Indeed. The broad categories start with basic manual handling, then move to manually operated trucks and trolleys. From there, we escalate to powered trucks and tractors, encompassing both operator-controlled and driverless computer-controlled variants like those AGVs we mentioned. We also utilize crane systems, conveyors, which we've already covered in detail, and of course, sophisticated robotics.
Among those, powered trucks represent a huge and diverse category, crucial for horizontal and vertical movement across warehouses. Can you list the main types we should be aware of? This seems like a core area.
There's a wide array, yes. The main types include powered pallet trucks, counterbalanced forklift trucks, Various reach trucks, including double reach and four-directional variants for specialized maneuvers. Stacker trucks. High-wrap stacker trucks, specifically designed for very narrow aisles, V&A. Side loaders for unique loads. Order picking trucks for fulfillment. Powerful tugs and tractors for towing. And even specialized straddle carriers used for container handling in ports and intermodal facilities. Each one is engineered for a specific task and environment.
Let's start with the most basic of trucks, non-powered hand pallet trucks. These are the manual workhorses you see everywhere, right? The ones people pull or push.
Yes, these ubiquitous trucks are incredibly efficient for transporting unit loads short distances, generally within indoor settings like loading docks or retail floors. However, it's crucial to understand their operational limits. Key numbers here. They typically cannot lift more than 8,000 to 10,000 pounds.
Okay, 8,000 to 10,000 pounds max lift weight.
Correct. And they cannot lift a unit load to a height greater than 8 inches. So while versatile for ground level movement, their vertical and heavy load capacities are quite restricted.
It's interesting how even these basic tools have evolved. What's worth noting about modern ergonomic designs in hand pallet trucks? Is there a specific force measure?
It's a great point. What's particularly fascinating about some of the more advanced non-powered pallet trucks is their ergonomic design. For example, a full-featured ergonomic pallet truck might only require about 34 kilograms of pulling force when fully loaded, thanks to design innovations like 2 articulating steering wheels and 2 front-load rollers. This makes it significantly easier and safer for a single person to move heavy pallet loads, reducing strain and improving efficiency.
Moving up to powered options, powered pallet trucks are very common for horizontal movement. What are their typical capacities and operational characteristics?
Powered pallet trucks are indeed very common for horizontal transport within warehouses, offering a significant upgrade in efficiency and operator comfort compared to manual versions. These trucks have capacities that can go up to a maximum of 2 tons. That's a key capacity number, 2 tons max. They are definitely preferable in terms of operator effort and safety, reducing fatigue. You'll find them in both pedestrian-controlled versions, where the operator walks alongside, and ride-controlled versions, where the operator stands or sits, depending on the distance and frequency of use.
Then we have the ubiquitous counterbalanced forklift trucks. These are the classic image most people have of a forklift. How do they work and what are their typical capacities? The range sounds significant.
Counterbalanced forklift trucks are designed to carry the payload forward of the front wheels. They achieve stability by using a heavy counterweight at the rear of the truck, creating a turning moment that inherently wants to tip backward, which balances the load's forward tipping moment. Their capacity is quite broad, yes. It ranges from 1,000 kilograms up to a massive 45,000 kilograms.
Wow, 1,000 to 45,000 kilograms. That's huge.
It is. They handle everything from standard pallets to heavy industrial components, and they typically offer lift heights up to 6 or 7 meters. These are incredibly versatile and vital pieces of equipment in almost any industrial setting.
For warehouses needing to optimize space and operate in tighter conditions, reach trucks come into their own because they're designed to operate effectively in a smaller area, right? Narrower aisles.
Yes, reach trucks are engineered for high-density storage and narrow aisle operation. Their capacity typically varies from 1,000 kilograms to 3,500 kilograms, with an impressive maximum forklift height reaching about 11 meters.
1,000 to 3,500 kilograms capacity, up to 11 meters high. How do they achieve that reach?
The mechanism is ingenious. It's achieved by having a mast that can move forward or backward in channels within the outrigger truck legs. When picking up or setting down a load, the truck can turn 90 degrees to face the load location, allowing for incredibly tight maneuvers and efficient use of space.
And building on that, we have double reach trucks. These are specifically designed for a particular racking system we discussed earlier, aren't they? Double deep racking.
Exactly. Double reach trucks are specifically designed for accessing double deep racking systems. This double reach capability can also be achieved on some lighter trucks by using telescopic forks that extend further. Beyond double deep racking, these trucks are also quite useful for side-loading pallets onto road vehicles, working efficiently from only one side of the vehicle, which can streamline loading, unloading operations.
Here's where it gets truly innovative for maneuverability in confined spaces. 4-directional reach trucks. What's the key difference that gives them their unique capability? This sounds specialized.
The key difference is this. On a conventional reach truck, the front wheels always face forward, and steering is primarily from the rear wheels. A 4-directional 4D truck, however, has the additional option of being able to turn its front wheels through a full 90 degrees and lock them in that sideways mode.
Ah, so the front wheels turn sideways.
Correct. This offers unparalleled lateral movement in narrow aisles, allowing the truck to move sideways with a long load, which is a brilliant innovation for handling long or awkward materials in tight spaces without having to turn the entire truck.
Then we have stacker trucks. What distinguishes them and where are they typically deployed? They look a bit like powered pallet trucks.
Stacker trucks are pieces of material handling equipment used to lift, move, and stack heavy loads, particularly pallets. They often appear similar in construction to powered pallet trucks, yes, but with the crucial addition of a mast that allows the load to be moved vertically to much greater heights. They are commonly found in narrow aisle applications, perfect for high stacking of relatively small loads where a full-size forklift might be too cumbersome.
For the ultimate in space saving, especially in towering warehouses, we turn to high rack stacker trucks, commonly known as very narrow aisle or VNA trucks. These sound like precision instruments for extreme height and tight spaces. What are the specs?
They absolutely are. These trucks boast lift capacities up to 2 tons and can lift pallets to impressive heights of 12 to 13 meters. What fundamentally defines them is that they're equipped with specialized mast mechanisms that can set down or pick up pallets from the racking without the truck itself having to turn in the aisle. This allows them to operate in incredibly tight aisles, often 1.8 meters or less.
1.8 meters or less? That's incredibly narrow. And VNA stands for?
VNA stands for very narrow aisle. It's the name given to storage systems where racks are configured as close as possible while still allowing easy access to every single pallet, maximizing cubic storage density.
Finally, we have order picking trucks. As their name suggests, these are designed specifically for a very targeted operation within the warehouse, getting individual items for orders.
Indeed. Order picking trucks are purpose-built to streamline and optimize the process of fulfilling individual orders from inventory. Their range is quite broad, from simple trolleys, often called roll pallets, for ground-level picking, to pedestrian-controlled trucks like long fork-powered pallet trucks, all the way up to sophisticated multi-level trucks that can elevate operators for high-level picking. These specialized trucks are critical for efficiency in e-commerce and retail distribution, where picking accuracy and speed are paramount. Key definitions for quick recall.
Before we wrap up this incredibly detailed journey, let's solidify a couple of quick, essential definitions for anyone navigating the world of warehouse and inventory management. First up, master carton. Simple definition.
A master carton is a straightforward concept. It's simply a large box that holds multiple units of a product. For clarity, it's also commonly known as a shipping carton or an outer carton. It's the packaging that bundles multiple consumer-ready units together for more efficient bulk transport and storage rather than handling each individual product.
And then the foundational concept of the unit load. How would you define that concisely?
A unit load is simply defined as a group of items that are packed together in a standardized way for easier transportation, storage, and handling. Think of a pallet loaded with multiple master cartons, all securely wrapped. That entire assembly is considered a unit load. It's all about optimizing efficiency in the handling process, moving many items as one larger, stable unit, rather than countless individual pieces. Outro.
Wow, what an exhaustive and insightful journey we've just completed. From the foundational strategies of various storage systems, like the sheer density of bulk storage and the nuanced differences between drive-in and pushback racking, to the dynamic movement facilitated by that fascinating array of conveyor types, and then into the cutting-edge world of ASRS with its specialized cranes and towering high-bay solutions.
Yeah, we covered how we accurately measure the efficiency of these intricate dances with metrics like vehicle travel proportions, RLE, TLTE, TI. Lots of acronyms there.
Definitely. And finally, we explored the incredibly diverse toolkit of material handling equipment, from the humble hand pallet truck, remembering those 8-inch and 8,000, 10,000-pound limits, up to the towering VNA stackers operating in those 1.8-meter aisles. We've truly unpacked so many precise facts, numbers like the 12 to 50-meter high bay range, and critical definitions, ASRS, VRC, AGV, MHS, giving you a serious shortcut to being incredibly well-informed on this crucial topic.
Absolutely. The next time you see a delivery truck being unloaded, or you're walking through a large retail store, I sincerely encourage you to pause for a moment and consider the intricate dance of these systems in action. Perhaps you'll notice this specific type of forklift, maybe a reach truck or a counterbalanced one, or identify a particular racking system like APR or even pallet live storage. Maybe trace the path of a conveyor moving goods.
Yeah, see if you can spot the difference.
Understanding these concepts truly eliminates the unseen efficiencies that power our daily lives, making the world work seamlessly behind the scenes.
And here's a provocative thought to leave you with as we wrap up. As we automate more and more of these complex warehouse systems, What entirely new skills will become paramount for the humans still working in these rapidly evolving environments? And how might these increasingly intelligent systems need to adapt to increasingly individualized consumer demands, like ultra fast, highly customized deliveries, without losing their hard won efficiencies? The future of logistics, driven by these innovations, is going to be a truly fascinating space to watch unfold.
Indeed, it's a field that never stops innovating, constantly reshaping how goods move through our world.
Thank you so much for joining us on this deep dive into the world of warehouse and inventory management systems. We hope you feel truly empowered with this new understanding.
We look forward to our next exploration with you.
Until then, keep asking questions and keep diving deep.